Okay, so we thank God, small, small, we'll get the work done quickly. Now, we are done with the basic things. So, as we are left with 2 weeks today and following week when I meet you guys, I'm done. The rest is for your project work, which is your group project work. Now, one thing about what we are doing is as we progresses, things becomes complex. I have to be honest with you. Things will become very difficult. So the ones that you were seeing was just for kindergartens. Today's session, you are going to code a lot. You're going to type a lot. So kindly take notes. Okay. And last time, Tony said you guys were, complaining. Guys, please, I don't have any option. And I was telling him that, you guys, this is the opportunity, the best opportunity that, you guys will have. Because if uh, if it was maybe physical, I don't think some of you won't even get time because everything I do in a week, you're supposed to complete all the things. But I'll give you 1 week and for you to do this. And I know some of you are married, you are working, I understand. But I told Tony that should you spend 1 hour a day or 30 minutes a day just to do something at least, able to complete it. Okay, so please kindly put in the effort because we are all we are all pushing hard to make sure that we get this thing done. Okay, you are not the only student busy. You know that I'm still schooling. I'm not done with my PhD yet. So all sort of stress also go and lecture, come and teach you guys. Okay, all sort of things, certain examination questions, certain slides. It's a lot of stress. You get it. But I still get time. So please, let's all, work hard. That is all I need. All right. So for the past 2 weeks, previous sessions that you've met, it was just introduction to Python and also learning some of the libraries. But today's session, we are going to build or we are going to um, apply the things that we learned, and we are going to build two things, or not. We are going to build two. Okay, linear regression and we are going to use a data set, and the next one we are going to use our normal mathematical formulas. Okay, then the following week or the next time that I'll meet you, we'll learn about classification where we are going to use the convolutional neural network. Okay, and I'll end here. I won't go further because of the online, I don't want to stress any of you. Okay, so let me rename this. How do we rename? Let me go back. Let me go here, rename your thing quickly, and we can take off. Okay. Please, if you don't understand anything, you draw my attention. And please, my ladies over here, things, you just have to put in the effort, okay? Don't give up. If you give up, please, it's not nice to give up. Linear regression, top house week 3. Okay, so, and I even told Tony that if you guys don't understand anything, you have to just let me know. Okay, so that's if you stay there. Okay, linear regression. Oh, top house more than week 3. All right. So I'll add my data set earlier on. Later. So let me clean this and I have it. So the first thing is we are going to this or come out with a linear regression. Okay, what is linear regression? I believe some of you have idea of linear regression. Can someone tell me something about it? Linear regression. Okay. Any idea about linear regression? Because you're not going to do the linear regression itself. Any idea about linear regression? Oh, you guys can go on and speak. Unmuted you guys, so you can go on and speak. Oh, nothing? Oh, all right. So linear regression, is something that I think we did it even in SHS, right? Where one quantity varies as what as another, either inversely proportional or uh, inversely directly proportional. That means as one value is changing, what is happening to other one? Okay, so there's a correlation. Okay, so most of the equations that we see, most of the linear equations that we see, y is equal to mx plus b. These are all linear regression equations. So when I change x, what is happening to what? To y. All right, and machine learning, the fundamentals of machine learning relies on this. The fundamentals of machine learning relies on this. Okay, so it's something that if you really want to dig deep into machine learning, you need to understand the basics of what linear regression. All right. So remember that machine learning and even artificial intelligence, it try to replicate nature, okay, but it can't get it exactly, right? So most of the models that we build, there's no way you train your model and you get an accuracy of 100%. I mean, if it happens like that, I mean, your model is overfitting. Remember, we learn overfitting, that when your model overfits, what actually happens if you know your slice or remember your slice, if your model overfits, it means your model memorize the data set that you train with it. Okay, and it can't generalize to unseen data set, or it can't generalize to the testing data set. You see your model has what has overfit, or your model also underfit. And underfit means your model could not, I mean, learn the data that you presented to it. Okay, these are the two things. So we try to balance it. We don't want our model to overfit. We don't want our model to underfit. So we try to stay in the middle. Okay, so uh, the model is based on touch. Okay, you're going to use PyTorch. Please mute yourself. You're going to use PyTorch. NumPy. So and you see some of them you saw, like all of them. All right. So my network, okay, I think it's back again. So you're going to see is some of them. Okay, so let me start. Change this one to Markdown and let's do some simple linear regression. Okay. We're going to use equation, so linear equation to so any linear equation at all. You can give me any linear equation that you want us to do it. Let me know. All right. So any of you can give me any linear equation. I want a lady. Any linear equation that you know. Y is equal to that equation. Let's be quick, guys. Let's be quick. I want to engage you guys for you to get the concept. Any linear equation or equation of a straight line. Let me see equation of a straight line. Equation of a straight line. Equation of a straight line, guys. Okay, someone is done. Who is that? Is it a lady or a guy? Hey, yes, but prove, yeah, so this is the equation of a straight line. So we know the equation of a straight line is equal to what? Mx plus c. In TM1, we 2 for fire. Okay, it's a guy rather. All right. So this is the equation of a straight line. Okay. Now, I believe you all seen this equation before, right? Y is equal to mx plus c. What is m? What is c? Okay, someone should tell me. Let's be quick, please. M is what? M is? What is M? Oh, you can unmute and speak. Let's be quick. There are a lot of things for us to do. So I'll be typing quickly because we are going to do this and also build one on a data set. So let's be quick. Okay. So M is the gradient and C is what? The intercept. Okay. By machine learning, we call the intercept bias. We call the intercept bias. So let me the gradient and see the intercept. Or let me the y-intercept to be specific. The y-intercept. Now you need to cast your mind back to the theory we did because I'm going to use or explain things based on the slice we did. Okay, the slice that we did with the machine learning thing. Okay, cast your mind back, because that is what. Yes, I'm going too fast too because we have a lot of things, Anthony. Okay, I need to complete two things over here. That is why the video is here. So you need to watch it again. I have to be honest. If I want to slow down, we can't finish. Okay, we won't be able to finish. So that's why the recording is there. Watch the video, please. Whilst you're at work, while you are free, you can be watching the video and getting the concept. But if I want to slow down, I mean, last time, yes, I understood your whatever you guys were saying. Yes. Now, I have two things to do here: build a linear regression for mathematical equation and build another linear regression for also data sets. Quite a lot of coding I'm going to do. I can slow down, but I won't get anywhere. And the work I'll give it to you guys, it has to cover everything here. If you want it like that, I don't have any problem. I can slow down, but the work is going to cover everything that I give you guys. So if that is what you want, you can let me know. Because as for the video is there. You can go and watch and watch and watch and watch again. But if you want to understand it at a time, yeah, I think it's not going to work. Okay. So now this is my equation. Y is equal to mx plus c. I said m is the gradient and c is what the y-intercept. Okay. How do I get what the sign on the formula? Which formula are you talking about? Which sign are you talking about? Speak, speak. I've unmuted all of you, unless maybe where the place is noisy. You can go on and unmute yourself and speak. If you can't hear Elvis, then check your network, please. But my network is fine here. Check your network. He said, how do you get the sign on the formula? Which
So,
sign? Yes.
the sign on the this and the what do you call it, the formula for the gradient. Yeah.
This one.
Yes, yes.
This is a dollar sign. This is a dollar sign. The dollar sign used to create latex. If you know latex, like mathematical fonts. That is why. So if I want to create mathematical font, I normally put it in dollar sign. Okay. Or we normally put in a dollar sign. I'm doing latex. I don't know if you know latex. Okay. Latex, you see, sometimes if you want to write mathematical expression, you can't use the normal font to do that. It will not work. So there's a new font out there called latex. You can Google and find out. Okay. This is the spelling latex. Okay. Latex, this one. So how do you, it's also like coding. If you know how to use the latex, you can write complex mathematical equation. And that is what I'm using. So this is a dollar sign. This is another dollar sign. This is y is equal to mx plus c. So when I run it, you see it nicely. It will render it. Then the m, I want the m to be mathematics or whatever. So that's why I have the dollar sign, I have the dollar sign here. But we saw this is a header. Okay. So header 2, heading 2. That's what you see over there. So when I run it, you see that it has made it nicely. See how nice the thing is. Okay. All right. All right. So the next thing is you are going to pick any equation. So now that we have y is equal to mx plus c, we know the m is the gradient and c is the intercept. Okay. We are going to pick any equation. So I want a lady to give me any equation based on the formula over here. So let's get an equation to model. So equation to model. So I want someone to give me an equation for us to model. An equation to model. You can type it in the chat. I want a lady. Based on this, y is equal to mx, or let me even add it straight away. Y is equal to mx plus c. So give me any equation that you are going to do machine learning right now for the computer to get the value for us. Let's be quick. Hey, my ladies. My ladies, so my ladies are sleeping on Lord Jesus. Eh? Say women empowerment. I'm empowering my ladies, but they are not minding me. Mm. Okay, the guys, you can go on. The ladies, they don't want to be empowered. Oh, any of you can give me the equation, please. Let's be quick. Okay, I want to engage you guys, or else me kase me any tama munti asi engine me engage mu akranka. Me some of the coding I will speed up over there. I want you guys to understand the equation so that when I give you the lab work, you'll be able to do it yourself and get an understanding. For the lab work, maybe I might give you complex equation. I'll use linear regression to determine the gradient and also the intercept. Mm. Victoria, are you okay? How are you doing? Last time I didn't see you.
Doing very well. I'm in the car, so the thing's a bit noisy.
You're in the car, you're not going home. All right, that's fine. Okay, so 2x plus 3. Okay, let's go. So Abubakar said y is equal to 2x plus 3. All right. So now we know that, let me space this one small. Okay, so now we know our gradient is equal to 2, where our c is equal to 3. So we can say where, all right, 1, 2, so where m is equal to 3, sorry, 2, right? Then c is equal to 3. Yeah, it's fine. So where m is equal to 2. So what we are going to do is that we are going to build learning algorithm or model that is going to determine this. But remember, it will not determine exactly. We're going to approximate it. You'll be able to see, some of these and appreciate what actually happens when we talk about machine learning, machine learning, machine learning. Okay. Yeah. Okay. So let's start. The first thing we are going to do, we are going to import our libraries. You remember last time we learned how to import libraries, right? But these libraries you are going to import, you are going to see some of them new. Some of them are new. Okay. So some of them are new. So you can check yourself and try to see what they are used for. So the first one, I'll import Touch, okay, library that is used for deep learning. Is I think it was designed by Touch. Touch is that is it Facebook? Yeah, it was implemented by Facebook. I don't know. Also, look at the spelling. Touch import and import neural network. Then we import matplot. After the last time we saw it, right? My network is going off. Hold on small before you come. Okay, that's all right. So import matplot as PHP, import pandas, PD, import Seaborn as SN. Then also import what? NumPy as what? NP. All right. Then we import some tools that we use to do some plotting. So toolkits.mpl or mpplot 3D. If you want to plot 3D, okay, this is what we use to add this 3D. Then from now, the next thing we want to do is machine learning. processing import standard scalar. Okay, I'll explain this to you later on. Then from scalar dot metrics, okay, import square mean square uh, mean absolute error. All right. Yeah. Successfully. All right. So these are the libraries that I'm going to use. So here, I can do something here. I say what? To import libraries. Libraries. So here, so what? Libraries. Okay. So once you're done, you need to run. One thing that some of you, when you do any, or when you type anything, you don't run it. You don't run the cell. I'm typing anything wrong here. I think it's supposed to be yes. Yeah. All right. Okay, so it's done. So this one is showing library imported successfully, and libraries have been attached. Right. All right. So we are done. The next thing we are going to do is we are going to plot that we will use, or we come up with a model for the model to determine the N and the C for us. Okay. All right. So create, or let's plot this. We have to plot this thing before using the map. Let's plot and yeah, let's plot it here. So we put our equation. Okay. So but first, let's get all the values we need. This is what the intercept. So create a variable to to get hold the gradient, and hey, the network is going on. All right, I'll see you. Okay, can you hear me clearly? The network went off, so I needed to pause so that. Can you hear me clearly? Or I'm still breaking, so that I can pause. When it comes back, then okay, it's back now. Can you hear me clearly? Can you hear me clearly, guys? Speaking on. All right. Okay, so let's go. So create a variable to hold a gradient and also concept. Okay. All right. So here we have we normally call the gradient weight. Another way for creating the gradient weight. So call it weight. Okay, the weight in the question above, okay, which is 2. So the weight is 2. Then the bias, which we are not going to call the intercept, so what 3. So what you have over here, as I said, this is called the bias, right? This one is called the weight. Let me change it. Look at what weight. Oh. Sorry. Go back on. Okay, this is fine. All right, so we have the weight for the bias. So here I created a variable to hold them. What is it? It is the weight is 2, the bias is 3. Now what I have to do is to create my data, my independent data. Okay. So I have them. So let me create independent data with my x value. Independent data, which is all my x values to my x values. Okay. You remember the x values we learn about what? The arrange, right? We learn about the arrange, remember? All right, so let's create one right now. So x is equal to, we use the touch. We're not using the numpy again because the numpy is far more advanced than the touch. So arrange, I start from 0 or, yeah, let's start from 0 because, I mean, we can even start from negative, which is fine. So you can start from maybe negative 3, then 3, or you can use the linspace. I don't know whether they have a range linspace. I'm just hoping there's something like that. Linspace. Let me Google to find. Okay, some of these things. If you are not sure, you check. That's what the internet is there. To touch linspace. I don't know whether there's something like that. Going over. Yeah, this is okay. So you can start. So you can start from the negative, then give a step. So you can give a step of let's see. Step of 10. Of 300, that it will be fine. Right. Once you have this, we can now calculate our y. What is our y? From the formula, y is equal to what? Weight, okay, my x plus one bias. So which is 4 is equal to what? 2x what? Plus 3, okay? If you get it, okay, you see that the weight is equal to 2, right? Then the bias is equal to what? 3, as you can see, right? So touch goes linspace 3, 3, then instead of 300, then like that. Okay. Are you okay? So let's run this. If nothing goes wrong, it's saying that linspace receive an invalid combination of argument got int. Okay, so I need to change it. Let me see what they said over here. Touch linspace, say got int. So I'm coming, guys. Touch linspace. Okay, give me the data type. Touch linspace 01 step 5. Okay. Linspace receive an invalid combination argument got int in step. Okay, we have this over here, but this should work. I don't know why this is not working. This guy is not zero though. Start and step. Wow, what is wrong with what I've done? It's telling me it's wrong. Touch limit space. I'm coming in. Touch limit space 310. Step 5. Steps or step? Oh, okay. You see, the thing is steps. I'm saying step. All right, so it will work now. Well, give me a so steps as a step. So I'll make it 300 because I can't use 10 is small. So I have my values now. Okay. So here, this is my independent. So this is my independent. So independent, okay, data or independent values. Okay. That's your X values. So here I create a dependent value, which is uh, dependent value, which is on my Y. Okay. So I have that one also here. All right. So now that I have this, I can now play with some stuff. So let's view a part of it. So let's view just a portion of our code. So view a portion of the data generated. Portion of the data generated. Okay. So here you have X. I want to view the first 10. Okay. So let me stand. You're going to see. Got it. Try to view it for me. These are my first 10, which is for that. So view portion of the data generated. They also view a portion of the Y. So let's view the first 10 of the Y. So if you put in the values, it's also supposed to give you, that. Yeah, so I think so. That's fine. Which times X plus bias. So from the equation we have, yeah, supposed to. So this is it. So just view part of it. Now you remember we learn about splitting your data. Okay, that anytime you are going to do training, okay, you need to split your data set or value generated. So you split your data sets into the main, we're not going to do validation. We'll do validation next week where we have to validate, but for this we can go on straight away. So train and what? And what testing. Okay, so the train is what we use to build a model, and the testing is what we use to evaluate your model. So an example of the train is what we are doing. So I'm training you guys. An example of testing is when I give you guys to do or allow assignment to do. So you split the data set into train and also what? Testing. Now, how many data sets do we have? We can find out how many by finding the length. So let's get how many values how many values are there. So we can use the length, this, and we can pass our X value, this one, X value to it. So if we pass X value to it, it's going to return. So in all, we have about 300 values. Now this is something small, okay? By your work, I'll give it to you. We'll crank it up. I'll ask you to crank it up to about 1,000 image sets or 1,000 values, okay? Yeah, so here is only 300 because why I specify only 300 over here. If I should have specified it to, let's say, 500 or 1,000, we'll have more. But 300 is fine. We can do it that one, right? All right. So now let's split it. So let's split our data, split it. Now, when you are splitting your data sets, we have a ratio that we use. We say the training has to be more than the testing. That's why in school, you spend almost like what? 12 weeks just teaching you, then use 1 week to write your exam. So that implies that training is what requires more time than what testing. Because once we train you and you know the thing, testing you is just a day. We can test you. You understand? It's like football game. Okay, Tony is not here. You just doing it training, then you go and play 90-minute match. If they score you, you're done. That's the testing. But the training, you have to keep on doing it. So the same thing you're going to have. So we need to have huge or large values for the training, then small values for the testing. So most of the time it is 70-30. Others also do 80-20. Others also do 75, 85-15. So it all depends on you. But we are going to use 80-20. That means the training is going to be 80% of our data set, and the testing is going to be 20% of our data sets. Okay, that means if I find 20% of 300, that's going to be 240, right? So 240 data set is going to be for our training. Then the 60 part of it is going to be for testing. All right, so let's split it. So here we create the train and the test split. So create the train slash test split. Okay. So here we have train splits. Now we are doing some mathematics over here. And one thing about the programming is more of logic. So I'll try to explain some of them, but some of them I will not. All right. So here, what we are doing here is that whatever length I had, what, 30%. So I had 300. So if I find 0.8 of 300, okay, that is what, 240, right? So this value is what I'm going to use to do my splitting. You remember indexing? We learned about the indexing, right? So what I'm actually doing over here is that get the 80%. If you get the 80%, which is 240, use the 240 to go and retrieve all your values. That's what I'm doing over here. Okay. So here I'm doing 80% training. So 80% training, then 20% of testing. That is it. 20% training, 20% testing. Okay. So here we have X train, then Y train. Now the train, they come in pairs. So if you have X train, you're supposed to have Y train. Okay, so the X train goes with the Y train. You don't separate them. Okay, they go in pairs. So here I'll take my X value, which the X value that I have at the top, then I'm going to index. Okay, so here what I'm saying is that give me from 1 all the way to the 259. That is the meaning. So give me all the one from, you could have even shuffle it. I mean, I should have even done shuffling, but that one is not important. Okay, I mean, sometimes one thing about it is that you just have to shuffle your code small, but let's move on because you don't have time. Then I'm also for the Y. Okay, so I pick from the first all the way towards to 259. Okay, that is what I have over here. So this is for my trainees. Now do the same thing also for the testing. Okay, so the testing also, we also have X over here. Then that one, I pick it from 260. Okay, 260 all the way to the last value. That's the meaning, as you can see over there. Then here too, I pick it 260 all the way to the last value. So here I'm doing indexing. That's really indexing. You can go back and watch that video again. So here I have it over here. So let's run. If nothing goes wrong, I can return to find the length of each split. So here I'll find length, X train, then length, Y train, then length, X test. Now please check the capitalization. It's convention. Most of the time, the X train we normally use capital letters for them. Then the Y values we use small letters. Goes wrong. Now so let's plot our values. So I'm going to use a function. I'm going to use a function because I want to call function. I'm going to take some context. I'm going to take some practice. First, I'm going to take train data with some train. Then to take my test data or test label. Test labels, which is for Y train. Then we have test data, okay, which is X test. Then we also have test labels, which is for Y test. Now, why are we calling them labels? Then our prediction, I'll put the prediction later on. So prediction is equal to none. Okay. Oh, none. Now, why am I calling them labels? In machine learning, we normally call the y values labels. Okay, because here what we are doing is that we are doing supervised learning. What you are doing is supervised learning. So when you see labels like that, remember that's a supervised learning we are doing. So the y values are called labels. Okay, y values are called labels. Okay, so I put my thing over here, then I can now do. So let's plot the training test and compare whatever. So this graph, or so plot training test data and what, and compare prediction. All right. So let's go. So as I said, things will become complex, but please, you don't give up. Okay. So figure, then we have a figure size. So how big do you want your graph to be? That is what I'm specifying over there. So I want it to be like this. Then here, come back. Here I plot the training data in blue. I specify the color I want the training data. So PLC, I use scatter plots. Right. Then I pass my training sets. Okay. So which is train data and train labels. This is typing. What is it? So the color, I specify the thing to be blue. Then my size supposed to be 4. That means how thick. And I want to create a label. The label is what is training data. All right. So I copy this because I'm lazy and do the same thing for the testing one. All right. Hafiz, you are typing. What is it? To plot the testing data to the testing data. All right. So here, you just have to change this one to test data. And you have test labels. Test labels. Then here the color to green, right? Then the state in labels. This is what testing data. Testing data. All right. Then the next thing is our plot. So let's see. So you saw this. If prediction, okay, is not none, then I can go ahead by plot the prediction in red. Okay. So you say that if I put prediction over there, I mean I have to type in red. So that's another graph that I also plot. So there are 3 different graphs I'm going to plot, which is the test data, the prediction, and also what the training. So we see all of them as we progress. Here, the color, I don't know whether I should use black. Black is key. You can use it. As equal to 4. Then labels, or label equal to prediction. Hafiz, you were typing. Oh. I don't know whether you are not done. Then I'll just show my legend. To show the legend. Okay, you know what a legend is? All right, pt.was legend or property. What property are we specifying it? Set the size to be 14. All right, put this one in inverted commas. This one in inverted. All right. If nothing goes wrong, I mean to plot this nicely. So let's see. Say duplicate test labels in a function. Okay, what is the test label? Test label, test label. Which line is that? Let me come put my line. Okay, couple lines. Let me run again. I want to know the line. Line 5. Okay. So line 5. Oh, I made a mistake somewhere. Test label, train label. This one not test label. Okay. Train label. Forgive me. My bad. Okay, so it's done. So now let's plot it. So let's plot. So I call my function. Call the function plot. So plot dot what prediction. Then bam. Okay. Okay. Add this. So let me remove it. There's no S over there. Okay. So look at it. Have you seen it? So here you can see the training set. Now this is fantastic. Do you get it? Because one, we've done nothing to our data. Okay, what we did was we plotted the equation. So this equation that we plotted at the top, this one. Okay, this is what we have over there. All right, so here we are saying that the blue line is the blue line is the training and the green one is all the testing. You get it? So we've done plotting. Now what we want to do is we are going to build a model and we'll train our model so that our model will try to see if it can also generate the same graph for us. Same graph. Okay, if our model can generate the same graph, that is what we're about to do now. So let's build our model. All right, so let's do the model. 1, 2. 1, 2. So build our model. All right. So create a linear regression model class. So we are going to create a linear regression. Now, I ask you guys to submit some work. I don't know whether you saw the classes inside. Okay, so we are going to create a class to do. So I have a class and I'll name the class linear regression. It's like a blueprint. If I say a blueprint, it's like how do you call it? How do you call a blueprint? A blueprint. House plan. How do you call it? House plan. Yes. So I'm going to create something like a blueprint so that I'll be able to use it to create whatever I do. So here I'm creating a class, and the class I'm inheriting it from the neural network module. All right. So this is known as a constructor. Okay. Known as a constructor. I pass cell to it. Then super. Then I have int. All right. So here I'm inheriting everything from the module. That's why you see the super over here. Okay. So let's do random initialization. Okay. So random initialization, because our model is about to learn. If our model is learning, okay, remember, it will learn poorly first start. Okay. So here I'm creating to run one. Then data type, you see the data type, you are seeing it over here, touch. But this time we're using the touch, then float. Then here, I'll explain this one to you, requires grad, which is so true. We do that. Okay. So let me explain that line so that things will be clear to you guys. So here, you see the weight over there. So the weight we saw here, that is the 2. So here, anytime you are training your model affects like you learning programming. Initially, everything is hey basa, right? So that is why here we are saying a random. So we assume that the student, they don't know anything. So that's a random thing over here. So we are generating random. So this is the weight. Okay, the weight you saw over there. We expect the weight to be 2. If not exactly 2, suppose we get close to 2. So we are creating a random value. That's what I say, random n. And we are setting it to float. And what you see over here require gradient. Now, touch has an algorithm to do the gradient for us. Okay, this I didn't want to take you guys through one by one step how the thing is done, because we don't have time. Okay, so this, instead of us doing the calculation ourselves, we are telling touch that whatever calculation you are going to do over here is going to do gradient, going to calculate the gradient itself, and propagate the error back like that. So that's why I say this. We are saying that the weight requires gradient. That means you're going to be doing calculation. That is the meaning. Okay. The same thing also with the bias. The bias I can copy and paste that one. That one too, I will set it up. Okay. I'll change it to bias rather. Right. Now what you have to do, sometimes you don't need to type everything. You can copy and paste some of the things that you've written. So here you set that. Then the next one is we need to do our calculation. And that is where the forward comes in. Okay. So the void comes in to be able to do the calculation for us. Now remember, all right. So what are we doing over here? What you are saying here is that we are going to pass the x value, which is what are the x values? These values that we did over here. We'll pass it to our forward. Okay. Now the forward is a function or a module they've written already. And what it's going to do is that it's going to do the calculation for us. Okay. But while doing the calculation for us, because we set the weight and the bias to gradients, okay, required gradient, is going to do back propagation. That means you do calculations and back propagate the error back and doing that over and over again to get the result that we are looking for. So here, you're going to pass the S value to you. You're saying that the S value is a tensor. Okay, then here, what are we returning? You're also returning a tensor. Okay, so if you see my return here, so my return is equal to cell dot what weight now times what. Have you seen this formula? Then what cell does? The formula we saw at the top there. Where is it? Where we're doing the calculation? Where's the formula that I wrote? Okay, the formula that we use to generate values. Yeah, this formula. You look at it. Let me even copy it. That I paste it over there for you to see that they are the same. So what you are doing over here, okay, you know the same thing. It's the same thing you're doing. But this time you're using a model, as you can see. So what we can, so we just do this. The weight times x times plus what? The bias. We're returning that. You get it? All right. So once you created a model, now let's farm it. Let's run it. If nothing goes wrong, it will run successfully. Now remember, you created a class. But you created a class, you need to create an instance of it. It's like you have your blueprints, your house plan. If you don't build a house, the house will be on paper. So what you've done is that you've created a class. For us to be able to use the class, we need to create an instance of it. We need to build the house. That's the meaning. Okay. Now, okay. So one of the things that we normally use a lot is something known as a seed in Python. Because we are setting a random value, you don't want the random value to be changing each time you run a cell. So we want to fix the random value that if the random value you generate is 2, make sure each time I run my cell it is 2. So we use the seed. So here we set manual seed. Okay, since n dot parameter out are randomly initialized. Okay, so here we have touch dot manual dot underscore seed and what 42. We have this. So this one will help us so that anytime this random thing we run this cell, it's the same. So if, for example, I ran this cell, we just ran this cell, and the computer generated a random value, let's say 4. Remember, each time I ran it, because of this seed, it will be 4 like that. Okay. Now, if your values will be different from my own. Okay, because it depends on the computer that you are doing. So if you do it and you're not getting my value, please don't get confused because it's a random value. Okay. So let's create an instance of it. So create an instance of the model. So I call it model, then I call my linear regression model. Then let's check the parameters that it generated. So check the parameters. Okay. Within the n module. Okay. So we use the list. Remember the list? So model dot what? Parameters. Right? Then bam. If nothing goes wrong. See, linear regression is not defined. Model is not defined. Linear regression. Hey, sorry. When I'm typing, I don't normally look at it well. All right. So if you work this time, okay. Touch n has no attribute parameter. Look at what I'm spelling. Okay. So sometimes, you see, when you make a mistake, you have to read the error. Okay. Last time Anthony was just, So let's look at it. So you read the error. So look at the parameters. So here, the system generated what? A weight. The weight is 0.33, which is far away from the 2, right? And look at the bias. The bias is 2. No, let me check. The weight is what? Let me get it. The weight is 2, the bias is 3. Okay. So this is the random value generated. So it generated a random value of 0.33 for the weight, which the weight is supposed to be what? 2, right? And the bias is supposed to be 3. So you see, it's like you learning fresh. You don't get anything. Okay. But what we say, when you say you are training your model, that is where you start learning. So we'll learn how to train the model, and the model will be good. Okay. All right. So we can also, put it this one also in a proper way. So a dictionary also can also give us whatever. So using dictionary, you remember we saw dictionary. So using dictionary, okay, we can view okay the parameters well. Okay. So here I have model dot what dict or dates, or sorry, state date rather. So that means this. Then if nothing goes wrong, so the same thing over here. So the weight is this, that is the same thing at the top over here. All right. You see here, it is telling that we require gradient. Okay, so that means this one will undergo some form of what? Back propagation calculation, gradient descent. Remember I spoke about gradient descent. Okay. So now what we are going to do is that we are going to make prediction. It's like I'm training you guys. Like the first assignment I gave it to you. So I train you guys first day and I'll give you guys something to do. That's your first prediction. But remember, most of the time your first prediction is weak or is going to be very bad. Okay. It's going to be very bad. But unless I train you over and over again before you're able to do the correct thing. So here the model came out with a random value of what this, which is far, far away from what we actually expect because the bias is 3, but look at the value is returning 0.128. And the weight is also 2, but look at the value is returning 0.333, which is what far, far, far away. Okay. So what do we do? If you make any prediction, don't worry, the system will not get it correctly, but we won't give up. We have to still keep on training the model. So let's make prediction. To make prediction, all right. So we touch dot inference. So when I'm making prediction, you put the model in inference mode. Okay, you put the model in inference mode. So put the model in inference. So now we create a new variable called y predict. Okay, that means what value are we going to get, okay, for this? Now remember the X test. So the data that was held out is the X test. That one, we didn't use it to train our model. So as you can see over here, we did that. So we have the X test, we also have water. So we use the Y train and the X train to train a model. Then the X test and the Y test will be held. So once the model has learned, they will now release the X test for the model to see if we can predict the Y test. That is what is happening, if you get it. So we use the Y train and the X train to train the model. Once we are done, we pick the S test, we pass it through the model to see how close it can get to the Y test. But you won't get the Y test. So when you pass the X test into the model, we call it Y predict. That means you are now predicting. You don't say X Y test again. So you say Y predict. Okay, Y predict. That's what we are doing. So let's see. So if nothing goes wrong, okay, so he's done doing it. Yes, so you have our code. I was expecting something to happen, but nothing happened. So let's print some values to see actually what we are getting if our prediction is actually correct. All right, so check the prediction. Okay, now some of the values, if I ask you to do the calculation yourself, you'll be able to do it, right? Yeah, because the number of testing samples. Okay, so we use len x what test. All right, then we'll do the same thing also for the predict. Remember, it is the Y test that we want to use the Y, or want the X predict, sorry, the Y predict to get close to the X Y test, sorry. All right. So we can even print some values, maybe 10 values of it to print. So number of testing samples, number of what? Predictions made. The number of what testing samples. So here is predictor values. Okay. So here we have this. We can count the next line so that things will become a little bit fuzzy for us. So let me delete this. We have what? Y predict this. All right. So the parentheses, I didn't close it. Line what? Line 2. What's my line 2? Line 2, line 2. Lost. What is showing my line 2? I've not matched the opening parentheses. This, this, this. Oh God, what is the error? I've not seen it. I'm coming. There's something here. Body is even tired. Yes. Yes. What's the error again? Why predict is not defined? I ran it, sir. Why didn't you run? Uh-huh. All right. So here, number of testing samples, number of predictions. So let's look at the value. So here, it just predict. So if you should go and look at our Y predict, sorry, our test. Okay, so this is a, so let's see the Y test. So I can do this. Next, we can also see the Y test. Okay. Let's see the Y test. So you just see the Y test so that you see the difference between the two. Okay. Y test. So we call them the actual values, not the actual. So let's see. Oh. All right. So let's look at compare the two. Have you seen this? Have you seen it? It's far away from the values. Have you seen it? It's far away. So if we should plot our graph right now, you see that it's going to be way wide across. So let's plot. So let's plot the Y predict. All right. So plot dot prediction. We've already created a function already at the top there. So just pass Y predict to it. And let me see whether I made the Y predict prediction. Okay. So once I have this, I mean, if nothing goes wrong, okay. So if you look at the graph, you see where the Y predict is. The Y predict is supposed to be on this or close to this. Supposed to be close to this. But look at where it is. I mean, the error is what it error not super, okay? But look at it, the error is huge. So we need to train our model. That means try to calculate the error. So it's like you teaching your child, okay, to do something. When the child makes mistake, you query the child small, then you show the person. So in machine learning and deep learning, what the model actually do is that if the model makes mistakes, it penalizes the model. It's going to penalize it. But when the model makes correct decision, it doesn't pay attention to it because we want the model to make the correct thing. Okay, so anytime they say we penalize it, but if it keeps doing the correct prediction, I mean, we encourage you to do it more, so we are not going to penalize it. So here, this result is bad. So what do we do? This is where we start training our model. So let's train our model now. Now, training your model, you have some things that comes in place. The first one is your loss function. To train your model require your loss function. Your loss function is the function that find the value between your true value and or your actual value and the predicted value. So let's go to the top over here. This is a predicted value. This is what the actual value. So the loss function is going to find the difference between these two. Okay. And the result that it will get, it will back propagate it. That is why if you go and read your slides, you see back propagation. You say you back propagate, back propagate. So the loss function will get these two, find a difference. So once it's determined that it will back propagate the error and share it equally. If I say no, not share it equally, but it's going to share it based on the errors each value presented. So like there's this saying that to him much is given, much is expected, right? So if you have more money, that means you have to do more things. I mean, that's the thing. If you have more talent, that means you need to do more stuff, right? So the same thing. So some of the values, they contributed much more to the error we are getting. So such people, we penalize them more. But those that contributed less to the error we are getting, we don't penalize them, much. That is what is happening with the back propagation and that. So we need to have our loss function. Then you can check the documentation. If you come here, we have a lot of them. Some of these things I keep showing you, but those of you who have interest, you can dive deep and learn some of these things. You don't use your head as a filing cabinet. Anything you are not sure, you Google. Okay, you Google. All right. I won't say generative AI, but make sure if you query it, generative AI can also explain it. You can say, explain this thing to me as somebody who's learning machine learning. Okay, they will break it down. So generative AI, try to query it in such a way that it will break this down. Can you say ChatGPT, explain this thing to me as a 15-year-old student? Okay, or somebody. When you try to be specific, generative AI, that's why we said a lot of us, you don't know how to use some of these generative AI. You just use it as normal thing. But if you can query it where you can explain concept and be able to understand. So the loss function, they are here. Okay, you can click on them, go there, there are a lot of them. You can look at them. Okay, so we have each one and what we use them for. So let's go to what I need. So here, these two is what let's talk about the cross entropy loss, and we also have this. We also have this thing. But I want to talk about these two. So this one is for the mean average error, and this one critical error, which is the mean squared error. So each one and what it does and what each one can do. You can read much about it and find out. Okay, find out. So let's define our loss function. So define and create your loss function. All right, so loss function is equal to nn. Now the loss function is inside, is 1 over this value is 1. Okay, so this loss function is the mean average error. Okay, that's the mean average error. All right, then we also create something known as the optimizer. You remember the optimizer? Who remembers the optimizer from the lectures? Optimizers. Who remembers the optimizers? All right, so the optimizers is like the person who directs your path. Okay, he is directing you that okay, pass here. Or if you are learning, the one is like, let me see the one, the coach or the mentor. Let me use that way. Is a mentor or the coach. Okay. And so he's just directing you that okay, Faha say. So like it optimizes. Is a word of optimization. So we have a lot of optimization algorithm. So we have the optimizer, which is touch.optim.sgd. You call this one the gradient descent. So stochastic gradient descent. You can Google and find out here. A lot of them. There are a lot of optimizers that SDG. Okay, optimizer. So which is you have all of them here. Stochastic gradient descent. Okay, as I said, those of you have interest, you can find out. There are a lot of them, Adam and all these things. There are a lot of them. So there's an optimizer that we use. As you can see here, there's even a diagram over here that shows you how some of these things work. Okay. Mm. So which is you have all of them here. Stochastic gradient descent. Okay, as I said, those of you have interest, you can find out. There are a lot of them, Adam and all these things. There are a lot of them. So there's an optimizer that we use. As you can see here, there's even a diagram over here that shows you how some of these things work. Okay. So set the optimizer. Then what are we doing? We pass our model, which is the model parameters. We pass it to it. Okay. Remember we said the model parameters, they require a gradient, right? You see, as you can see over here, it requires gradient. That means we are passing these parameters to our optimizer. So we are saying that calculate the loss function, but make sure that the calculation that you are doing, you'll be able to what? Direct it in such a way that whatever we are looking for, we're able to get it. Okay. So that's why we are passing that to it. Then there's one more thing called the learning rate. The learning rate. Let me even use three. The learning rate. What is the learning rate? This one too is paining me. You guys didn't do quizzes. It's paining me because I don't know if you have been reading the slides. Okay, so the learning rate is a value that we use to control. Okay, we use to control our gradients. We use to control the gradient. Okay, the gradient is like steps. So either you have a longer stride or a shorter one. So the stride that you are using to get to your destination, okay, we use the learning rate to control that. Okay, so you learning something, your coach is optimizer, but you need something to be able to control. Okay, so you're going to do maybe 1 hour, 1 hour, 1 hour, 1 hour. That's your learning rate. Or you want to do it 2 hours, 2 hours, 2 hours. That's also your learning rate. Or you want to do it 3 hours, 3 hours, 3 hours. That's also your learning rate. Okay, so the learning rate controls the step. Should I go in a bigger step or shorter one? And that one, we have values. You can go and read about it. Okay, we have values. Sometimes the maximum you can go all the way to 0. I think this is fine. It's gone. But the value alternate between 0, 1, 1 and 3, 1 and 3, 1 and 3 like that. Okay. So this work we can do like this. But remember, I said all these things that if you choose a smaller or a lower value learning rate, it takes time for your model to converge or to find the correct answer. But if you take a higher value to your model will converge quickly, but the answer might be far away from the actual thing you are looking for. Right. So these are things you normally. So people who do machine learning, they spend a lot of time because some of these things are things that need to be optimized by the user. Okay. So parameter. Okay. So it's going to run, but it's going to take some time. Okay, so now let's train our model now. So we're now going to train our model. We are still under the training, so let's start. So we still use the touch, but manual to make sure that our value stays the same. Speed 42. So anything I do. All right, so let's set our epochs. We set the number of what? Epochs. Oh, epochs. All right. Now, when we talk about epochs, what are we saying? So let's find out what an epoch is. So now when okay, or epoch, I don't know how they pronounce it, but When you say epoch or your epoch, we are talking about a complete pass through the entire training data set. Okay, that means we are going to talk about, you let me code everything so that I'll be able to show you what an epoch is, or else you get confused. So we said our epochs, then we're going to create some lists to track our values because we use them to be able to do that. So create, also set the epochs. I think epochs 10,000 will be fine. Okay, or less, I think 10,000 will be fine. Then we have what? Create empty list. An empty list to track values. Okay, so train loss, values, you create an empty list. Then loss, values also create what? An empty list. Then epochs count, because you want to know how many epochs you are going. I want to create what? An empty list. All right. So for epoch in range, which is epochs, we did this one before. All right. So let's go. So we are now going to do the training now. So first we put the model in training mode. Okay, so like you need to tell the model, hey, guy, get ready. I'm going to train you. So model dot train. This is very, very important. You need to put a model in training mode so that you will prepare the model for training. Then we are going to do forward pass. The first one is our forward pass, which is 1. Okay, so the forward pass on the train data using the forward. You remember I made mention of the forward, okay? All right, so let's do the forward pass. So each forward pass, what we do, we create, sorry, we do prediction, okay? For each forward pass, as you can see over here, we are doing prediction here. As you can see, we are doing prediction. So we are returning, we are doing the calculation, put it inside. So that's why here you are seeing that the forward pass we have what y predict is equal to model train. So once you are done with our forward pass, the next thing is to calculate the loss. So number 2, all right, so we calculate the loss. So once we do our prediction, we need to make sure that the value that we predicted, okay, and the should I even say the value that we predicted, is it y train? Am I making a mistake? As I'm coming in, let me take my way out here. Okay, yeah, it's correct. Using train over here. I was just looking at one use train, so here must be train. So here, whatever prediction the model will do, okay, you're going to find the difference here. Then the loss function will do whatever calculation it will do and to return the loss. So once it returns the loss, we need optimizer, okay, to be able to so here because something 0 graph, and I'll explain things later on over the optimizer. All right. So what we are doing is that for each pass, okay, when you go through the loop, you say you're going through a pass. So each pass, some things are updated. So sometimes we need to watch zero the gradient, or else the gradient will keep accumulating, and that's why we don't want that. That's why we are zeroing the gradient. Okay. Then the next one is loss backward. That means backward propagation. Okay, so I'll say backing here, so back propagation, so back propagation. So that means we back propagate the arrow, sorry. We back propagate the error. And this is where we share the error. So backward, see the backward. So here we are doing back propagation. So once we finish, we now optimize. So we optimize which is optimized to make sure that the back propagation is shared nicely. That is actually going to optimize that. So this is what actually, so here, this simple thing here is the machine learning we are talking about. Okay, so you do your prediction, calculating your loss, optimizing, zeroing your gradient, doing back propagation and optimizing your step. That is all. So all the things we did are just we're preparing. So if you remember the pipeline, remember the pipeline? You do data collection, data pre-processing before you even come to build your model. So building a model is just twinkle of an eye. Just do it quickly. But before you get to that place, there's a lot of things that you do. Right. All right. So now that you've done that, the next thing is to now do some calculation and get whatever thing you are looking for out. So let's put a model in an evaluation mode. Okay. So put the model in what? In evaluation mode. Now, in actual sense, the top is actually training. So I can put some things over here. I say what? Training here. Okay, so here I'm just training my model. Then when you get to the evaluation, here we are testing. So once we're done with the optimizers, we go all the way and we say what? Testing. So here we are testing. Okay. So let's start. We pick our model and we put it in evaluation mode. That's what we've done. So once you put our model in evaluation mode, that means it's ready for us to do testing. So we touch dot inference mode, right? So we start. We go to the same thing that we did, which is the model, this and test and all these things. So I can copy the same. So we do the same first part, but this time we'll do it on the testing data. Okay, so the first pass. So do the first pass on the test data. So the same thing we did. So test predict is equal to model what x test. Okay. Then so here we calculate the loss on the test data. The same loss. So we have loss here, which is equal to loss. We already have the loss function defined at the top. We just have to call it. So test predict minus y test. Okay. Then we have our type. I think we have to set the type to float or else it will not work. So touch dot what? Float. Okay. Then the next one is we print. So print out what? So print out. So let's print out. So if epoch modulo 100 is equal to 0, then we have our epoch count. We append it and we do this. Then we have our train loss values. We append it. You remember the append we were talking? So loss the CPU. Now here, but numpy, we are moving the data from the denser all the way to that. So okay, that is something that we have to do so that we don't waste. Or else it will give you an error. Okay, the same thing with the test loss. So when you see the CPU, that means you are moving the data from whatever device, okay, that we loaded it. Okay. Now next week, you see that we'll be using some GPU to do our training. Then you see some of these things when I'm talking about it, where we try to move. Okay. So the epoch, okay, then we have what the my train loss is loss. Okay. The my test loss is your test loss. All right. So if nothing goes wrong, when I run it now, this epoch, as you see over here, as I said, we call it the number of passes your data set has to, your data set has to go to the model. Okay. So here, as we saw at the top that when we did the random, it was bad, right? So we use the epoch. It's like a footballer trying to train. Okay. So the footballer will hit the ball over and over and over and until the person is able to what? Control the ball well. Okay. That's the same thing over here. So we the epochs is the number of times you pass the data set or the training data set through your model. So each one, the model gets better and better and better in knowing your data. So sometimes because of computational resources, we don't have servers here. Okay, but this data we are dealing with is something small. But if you are dealing with images, where you are dealing with a lot of them, like 20 gig images, hey, you need serious servers. This is where GPUs and now Nvidia is now making billions of money because now all AI systems are trained using what GPU. All right, so the epoch, this is going to happen 10,000 times. So each 10,000 times we pass the trained data through the model, then we check the error, we update like that till the model gets better. So let's start training to see if there's no error. All right, so touch is not defined line what? Okay, so I'm going to put R here. Epoch is not defined. Line what? What's the line? Line 48. Somebody's getting tired. Let me make it small and I did that way. So let's see. So you see it's training. So going. So let's look at it. You see, if you look at the loss, the first loss we had was this, and the test loss was this. But you see, the loss is coming down. Now this is crazy because the loss has come all the way to how many? It's almost at 0%. Now there are two things. Either my model is overfitting on the training sets, or the model is actually working perfectly. So for us to be able to know, unless we plot, be able to see what actually is happening. But if you look at it, the loss is what is decreasing. So let's try to plot and see what actually is happening. Okay. So let's plot our curve. All right. So let's plot it quickly. All right. So let's plot the loss to plot the loss curves. All right. So PLT, we have our epoch count, train values. So train loss values, then label what train loss. So we want to see how our distance actually faring, the two things that we did. Sometimes when you use diagrams, that one is far better, okay, than you using the just looking at the values. Okay, this one is a test loss. Then we have some title on all these things. So remember all the things that we learned: the title, training, and test loss curves. Then we also have what PLC or what Y label loss. Then what do you have? PLC, X label or epoch. And the next one is what? PLC dot what? Legend. All right, so we have this now. So let's see if there's nothing wrong. You're supposed to see and so let's look at it. So you see the test loss. If you look at the train loss started from here, but look at where the test loss started from. So you see the test loss started from 6. That means the model was struggling to answer the question correctly when the model was doing the quiz. So here, but as time when we started training it over and over again, it's able to get it correct. You see it over here, right? So that is that. Now let's see whether our model actually learn. Okay, whatever our model learn. So find out to find our model's learn parameters. So our models and parameter value we had, which is the the weight and also the bias. So let's see whether our model was very close to that. So print. So the model learned the following values for weight and our bias. All right, so we print. Then you have our model, dot state, dictionary. Okay, so we do that. Then print again. Okay, and the original values for weight and bias. Let's see. I'm just hoping the model didn't overfit, because after this we're going to have some calculate evaluation metric. Metrics is bad. That means our model actually overfitted. This is people spend nights, okay, trying to get what the thing. So let's look at it. Wow, our model actually overfitted. And you see, this is the original. The original is 2, and I'm thinking the model overfitted. Just 3. What do you think? What do you think? Was it's right, 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 right. Hmm. What do you think? Oh, Jeremy. Hello, guys. Are you hearing me? Okay. Okay. So I was asking that if you look at the value, this is the original one. The weight is 2. Here we had a 2.0004. And I'm saying that maybe the model overfitted. That is what I'm saying. The model overfitted somehow. Okay, so let's see. Let's use our evaluation metric to see whether actually our model overfitted. Okay. And all these, as I said, I mean, it's up to you to make it better, especially your lab assignment like this. If your model overfits, it's up to you to make sure that it's able to work. I'm thinking it will be from the loss function. Maybe I have to go and decrease the loss, the learning rate. Okay. So let's calculate our y predict and use it to calculate for the, the evaluation metric. Okay. All right. So, or do you even have it? Because I don't think the test predict. Yes. Yeah, we don't have the y predict. We don't have the y predict. So let's do that quickly. So here, so let's set a model again to evaluation. So that's the model. Okay. You know what? Evaluation mode. All right. So we have model again. Not what? I do that. Then here, I'll do my training. So with touch dot inference underscore mode. So what do? I have my y predict over here. which is model. Okay, then what X test. All right. Once I have this now, I think I'm good to go. Let's plot. So let's have our evaluation metrics here to see. So the evaluation metrics are going to use the root mean square. Okay, so first I'm going to use the root mean square. All right, so you have RM. Let's see. Now this, the higher the value, which is if I say the higher the value, that means the closer the value is to 100, the more, better your model is at learning. Okay, but if it exceeds 100 or is less than 0, it means either your model is underfitting or overfitting. That is the thing. All right, then let's also have the root mean squared. Sorry, the R squared. Okay, so the R squared measures correlation. All right, so we also have the mean squared error. Okay, which is even the R squared. No. I'm supposed to use, I think I got that one at the top there. I'm supposed to use the R2 square, not the R square. Sorry. Oh, you okay, R2 score. Yeah, that's what I'm looking for. That one you pass, I think the S test. So I predict. Yeah. So let's print both of them. Okay, so RMSE value is your RMSE print R squared is, all right. So let's see whether things work. Wow. Now you see, if you look at my root mean square, have you seen it? I mean, the model is I don't know whether the model is overfitting or underfitting because this is so bad. The root mean square. Let's go and find out about the root mean square. Okay, root mean square error. Let's find out what is it. So Wikipedia. Yeah. So let's look at it. So the root mean square measure, blah blah blah. I mean, it's over here. Let's look at its importance. Okay, in machine learning, what does it do? Okay, let me just add it in ML. So the higher is it, the better is it. All right, so the root mean square value use metric to measure the average magnitude of prediction error in regression model. The square root of the mean square difference between actual volume expressed the same. Okay. So this compute manually by applying blah, 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 the formula. Okay. The low mean square indicate that the prediction are close to actual value. And I made a mistake. While a high suggests larger errors. Oh, okay. Oh, then forgive me. However, each interpretation depends on the scale of the target variable. It should be compared across. Wow, let me look at this. The explanation of this. Okay, I was thinking in terms of accuracy rather. So let's see interpretation. Okay. So the root mean square is interpreted as the average prediction error, which determines the model prediction accuracy. Which simply shows on average how far the predictions are from the actual values in the same scale. The lower RMSE suggests a smaller average prediction error, and hence more accurate prediction. But the acceptable depends entirely on the context. Oh, okay. All right. Well, okay. But this is too much. Because I'm thinking the model is overfitting. Can't you see? 0.008. Then the model is accurate, Papa. Okay, and the R squared value to is almost 1. This is serious. This is serious. Okay. But you can make it better. You can make it better. So this is about it. So let's find out. Let's plot to see how close. I think it will overlap. I'm thinking our model, our graph, well, yeah, our model, which is our graph will overlap. So let's see. So let's graph or let's plot our predicted value to see. So plot. So here we already have the plot. I've already have that one. So I just call it and pass the y predict to it. Okay, I'm just hoping. I mean, no, it's too much. It can't lie on it perfectly like that. It can't lie on it. It's supposed to get close, but this one is like a line on it exactly. Okay, because you see, initially we had the error when we plotted where it was. It has moved all the way to line perfectly on it, which I mean is some way, but I mean it's correct, but it's like a perfect prediction. But when it happens like that, as I said, either your model is overfitting, your model is memorizing the data that you gave it. You gave it. All right. Any question? We are not even done on because and it's even 10 o'clock. Okay, we have the homework, lab assignment I give it to you. We have a full practical work that you're supposed to build from a data set. Okay, so I don't know. What do we do? What do we do? What do we do? Hmm. What do we do? Should I continue or maybe you want to rest? Because what is left is we need to play with the data set. What we did was we generated our own data set. So what is left is we have to generate one data set right now. Sorry, we need to upload one data set to our workspace and create a linear regression for it. Okay, if you are tired also, I can pause. Then we have to find a way. Because the work that will come, I'm going to do two things. I'll give you a linear equation and ask you to predict the value, and also I'll also give you a data set and ask you to build a regressor for it. So let me know. Anthony, should I continue or should I end here because it's almost 10? Hello, Anthony. Okay, so I think uh okay, so maybe if you guys are tired, you can drop off. But this is what I did for the level 300. I think it was time to the drop off, but I continue, and because the video has to be complete. The video has to be complete, so I continue again. But some of them said they have to go and pray and all sorts of things. So I told them that they can drop off. Those who drop off should drop off. Then I continue to complete it before sending the video to them because you have we are left with the other one. The other one is very simple. That one we have put our data set and get it done. So please, it's 10. I have to make it a complete tutorial so that when you are doing it, your project work and also doing your lab assignment will not be because this one I'm not sharing any cheat sheet. So you can drop off, right? You can drop off if you are tired. But I'll continue, even if I'm the only one here, I'll still continue because I want the video to be a complete one so that you can use it to do your work. Okay. All right. So that is that. Right. So the next thing I want to do is now import data and use it to build a linear regression. So this time I'm going to use what real world data. I'm not generating my own data. Okay. So what I'll do is first I need to get the data onto my workspace. So here is linear regression using our actual data. So linear regression. So using what which is real world data now. So what I used initially, or the first one was just my own generated data. Okay. So you're going to build another linear regression where this time you're using what? Reward data. But before you use the reward data, you need to add the data to your workspace. Data to our workspace. Now, what is the name of the data that we want to add? We come here, then we click on what? Input, then we click on data set, and we type the name of the data set. The name of the data set is advertising, okay, advertising data set, and it is done by this Tofik El Wali, this guy. You check the name before it is done by this. So advertising data set is done by Taufik El Wali. So I'll click on this, then it will be added to my workspace. So once I have it, when I come here again, close this, then come here, I'll be able to see it over here. So I can open this, then you're going to see it over here. So let's look at the data sets. As you can see it, so it's made of two TV, radio, newspaper. So we call the TV, radio, newspaper, these are the features, and the sales is actually your target. So in that sense, we are going to build a multilinear regression where we are going to see how these things relate to this. Okay. So in companies, people want to see, okay, so which one is going to give us the best output? Okay, the best output. So that is that. So here, this is my feature one, feature two, feature three, and this is what my target. And how many of them? I think there are only 50. There are not many, so we can do that easily. Okay, a minute. All right, so these are the data sets. Okay, so we've seen it. They are not many. Okay, but maybe the one that I'll give it to you for you guys to try is going to be a lot. Okay, so just follow the same thing. So let me close this. I don't need that. So the first thing I will do is to okay, where am I? The first thing I will do is to okay. The first thing I have to do is to import the data to my workspace. So let me get the data to my read the data set. So we use DF. Then remember last time we use the pandas. So we CSV. Then here I come here. I don't want to type everything. I come here. Then I'll come here. I'll click on this to copy the path. Once I copy it, I paste it. That's my full path. So I execute my cell. Once it's done, I can view the data set. So df dot head, and I just view some part of it. So this is my data set. Okay. Now, if you look at the data set, or if you look at the data frame, you have some unnamed thing over here. I need to remove it. This is where we call something data pre-processing. So you need to pre-process your data before you feed it into your model. So this is I'm dealing with the real world data now. So I need to remove the unnamed from it because I don't need it. What I need is the TV, radio, newspaper, and the sale. So I need to remove this. Now this, leave this one. This one is the pandas that is trying to index it for you. So we need to do this. So how do you do this? First, I need to get my column. So return the columns. So df.org columns. So look at the columns. Now you need to pay attention to how the system actually named the columns. So I need to drop this. I don't need it, so I need to drop this. So let me drop. So drop the unnamed. One thing that some of you drop. Okay. Then I said, okay, in order to prevent any confusion, the first thing is I have to copy this, which is far better, so that I will not struggle. Okay, so I drop on which I want to drop it on the column as is. All right, so if nothing goes wrong, if I come back and say df.head again, then I want to view the first 10 again. You see that Now the unnamed is gone now. So now my data is clean. My data is clean. So I have this, that. Okay. So now that my data is clean, the next thing I have to do is to split my data. I'm going to split my data. Okay. So remember, as I said, TV, radio, newspaper, column, they are the features. Then the sale is the target. So I need to separate this. Remember when what we did at the top, we had what? We had the X and the Y. It's the same analogy here. The X is going to be the features, the Y is going to be the target. The X will be the features, the Y is going to be the target. So I need to do that so that I can feed it into my model. So we are going to we'll build another model again. I'll be going up to go and copy. And as I said, it's not crime if you copy your code that you've written at the top already. You don't need to type every time. Okay. So let me split the data into features and also what? A target. So split the data frame or the data set into features. With the features we saw, it will be what? Features and also targets. Sorry. And also what? Targets. Okay. So we have this now. So my X is actually my feature. So df.drop. So I said drop the sales. I don't need the sales. So drop the sales. All right. On which axis? We drop it on the column axis. Okay. Then you convert it to NumPy for me. To NumPy. Okay. I want it to be NumPy because this one is a data frame. Okay. It's a data frame. So I convert it. So what I've done is that I've dropped this. So I only have TV, radio, newspaper, everything being put into X. Then I also do the same thing for the Y. With that one, I'm not dropping, but that one I will actually do something known as well indexing. So I'm taking the sales and put it into this. Okay, I could have taken the individual TV, radio, newspaper and put it into the X, but that will be a long process. But since the targets, so let me make this one the features. Okay, so this one the features. The target is only one, so the best option is I just have to use that one straight away. So that one to I get it. Or another word is also can also be the label. Okay, that's the label. All right. So I've done this now. So let's run it. So now done that. The next thing is I can view the shape of my data set. So let's view the shape. You remember the shape or the dimension. Remember we learned this last week. Okay, so I'll take my X dot shape, then Y dot your shape. All right, so let's look at this. So here, look at it. So it's telling me that I have 200 rows. Then how many columns? 3 columns. Okay, for X, which is 1, 2, 3, which is true. Then the Y, how many shapes do I have? I have 200 rows. But this is like a vector. Here is a vector. So it's something that I have to change later on when I'm feeding into my model. Because the model will get confused with this. All right, that is something I will do. Right. So having done this, the next thing is that let's split. I think I have to put things so that things will become a little bit clear. So here, to load the data set. Okay, so we've done that. Then here, we drop to load the data set. So here, we drop. Okay, we drop columns not needed. We've done that. Then here, we now split. So split and what target. We've done that. Then we now come here to split it into split data set into three data sets into train and what test. Okay, so that is what we are going to do now. So the same thing we did at the top. I don't want to waste time, please. I just go and copy the same thing because we did that. All I have to do just tweak things. I don't type everything because I'm lazy. I'm tired. All right, so I come here, I copy this, right? I bring it all the way down. It's not a crime, as I said. No one will penalize you. All right, if you do that, because you wrote the code. So here I create a train split. So here instead of doing train split, I'll use something else, which is I do the same thing. Okay, I space it out. Then here Y train, X train. Then the same thing here, I'll just change it. I'll not use a split because I want a proper name for it. All right, so X. Over here, okay, also have to do so that you don't have to type a lot. Okay, so one, you just copy that. Then you can find the length. So find the length. All right, so here X train, right? Y train, then X test, then Y test. All right, so let's see. As you can see, you see the train, they are 160 and the test are what? 40. All right. Now there's something we have to talk about known as normalization and scaling. Okay, scaling or normalization. Now I don't know whether I did explain this one to you that machine learning. Okay, so here let's look at this. Now because in machine learning we use numbers a lot. The higher the number, the more important the model would think that, or the higher the number, the model would think that that feature is important, but it might not be true. So what we do is that we try to all the features on the same scale, the same scale. That is why those of you who are into the medical field, sometimes you have to write certain exams to make sure that all of you are on the same scale. Okay. So here, if you look at the TV, if you look at the row zero, it is 230. Now, if you look at the radio, it is 37. If you look at the newspaper, it's 69. The model would think that the TV is much more important. So it what? It will be biased towards the TV. What happens like that, it makes our model be biased in such a way that it will pay attention to more values or the values that are what are higher or larger, leaving the ones that are small. So what do? We need to standardize or normalize our data or features. Normally, we don't normally normalize the targets. Okay, the features that we normally normalize. We normalize the and also the sales scale. This is very important so that it will enable our model to be able to learn. Okay, be able to learn properly. Because this one is actually 3D, plotting 3D becomes a challenge to do that, but I might skip it. Okay, I will skip that, and yeah, I will not plot it, but I will skip it. So let's normalize it. So let's normalize our data set. So what I will let you, maybe you know, I'll stress you. Maybe the lab assignment, I'll ask you to normalize it and do training, and normalize it and do training. Let's see. So that maybe I'll let you guys do that. So is equal to, all right, then with standard deviation, that means the normalization, use the mean and standard deviation to do. There's a formula you can find out, which is let's see, normalization and standardization. ML. The formula that you use. So as you can see, the normalization, whatever, normalization also there. You can and check some of these things yourself. Okay. So here I'm going to use normal to do not use the tag, use the train. So the train says to everything, then and here after you know that we use the already scalar transform both scalar. Okay. How bringing on why you not do that? Okay, so a minute, then let okay, this one is just falling like that. Okay. So I'll finish right now. You have done well. I don't know why some of you. Okay. So here, uh, so I transform it again, right? Then transform it also same thing, which is the x. So you didn't see the target over here, right? So as I said, we are not going to plot, so we go straight away to build our model. Okay, so but if I plot, it's actually 2D. Standard scalar is not defined. All right, did I even import it? Did I even import it? Standard scalar, okay, it's E rather, not A. All right, so I've done my transformation now. So let's build the model. All right, I will plot it, but plotting it will not do anything. Okay, so let's move on and let's build a model quickly. All right, so build a model. So the same model that we built, we're going to build it, but this one's going to be a little bit different. Okay, it's going to be a little bit different. So this, I can go and copy what the model I started building at the top, so which is my model that I wanted to build. So where is it? Yeah, the guy is here. Let me copy everything. So I bring it down. Okay, then I paste it. So these are ways to do things. So this one too is linear regression model version 2, because there are two different versions. The other one we did over there was the version 1. That one I made it linear model, but I didn't. Here the same thing we pass through the same super, but this is going to change. I'm not going to use random initialization. Okay, this one I'm using real world data. We use the neural network, okay, the linear for creating the model parameters. Okay. Now, why am I using this? Because this one is real world data. You see, the first one that we did, we were actually cheating because we knew what we would be getting. But this, you don't know. So the only thing you can do is that you supply the model. These are my features. So I'm going to tell the model that my in features, what is whatever I'm passing into the model, I mean, the feature is supposed to be 3, and whatever I'm getting out is supposed to be 1. So if you look at our table here, we are passing 3 features, 1, 2, 3, and we are targeting only 1. That's why you see what in feature is 3, out is 1. So here I'm passing 3 features. So if I give you, I mean, a data set that is different from my own, and there are 4 columns, 1 target, you have 2, 3, 4, and 1. Can you take note? And we do the same thing for the pass. The pass thing, that one is the same. We taught tensor to tensor and linear. So here we are not doing mathematical calculation, but we are going to return the linear calculation at the top there, which is the linear layer. All right, so we are going to return this, right? So what we are saying is that we are passing whatever that we get, which is this value, we pass it through the linear, and the calculation we done over here. And that is all. We are done. The model is done. So here we define something known as what? The forward computation. Right, so we define the forward computation. All right, kind of forward computation. I think that is all. So you know, any big deal. All right. So if nothing goes wrong, let's remove this. I don't need this here. Okay. So I run this. Okay. So the model is done. So we call as we did the same thing. So I'll make it model version 1 because I made it. So we set the manual, okay, speed. All right. So here we have touch is equal to manual, then speed you use of 42. As I said, if I want to get the same thing, okay, so here I make a model bin1, all right, is equal to what? The linear regression. Already I can copy this. I don't want to. Okay. Okay, then I put this one here. Then model version 1. Okay, then model version 1 again. What else? The parameters we pass this. So let's see. If you run this, it's going to tell you that this is a linear. You see, because we don't have time, like you guys really enjoy the course. You see here, it's telling that this is regression. How many have in feature 3, out feature 1, right? Bias is true. That means I set the bias. Remember the bias? Okay, so here we didn't specify that, but the computer, I mean the model itself is doing that for us. Then you see here, we call this one the weight. The weight. So you see how many values you have there? 1, 2, 3. So it's just trying to generate some redundant value that is going to help us be able to get a target. And this is the bias. Okay, we don't have the target over here. We don't have the target over here. So if you remember the first one that we did, it's similar, but this one we're using real world data. The reason why we have 3 weights over there is that we have 3 columns. Each column will have a specific weight. So what we are trying to do, we are going to map. So what we are doing is that we are trying to put all these 3 together and map it to sales. That is the meaning. We put all the 3 features together and try to map it to sales. So it will try to generate redundant value at first, which we said if you generate that, I mean, it's not good. Okay. Now, one thing I didn't talk about is okay. I even made mention that generative artificial intelligence is now relying more on what graphical processing units. Okay. And most of the training that we've been doing set it the time to CPU, but I'll show you how to do this right now, so that next week when we are dealing with this, you're able to see. So here, if you come to setting and you see accelerator, you see that it's set to none. Now we have some GPUs over here. Now these GPUs, Kaggle gives it to us for free, but you can use it throughout the whole day. I think you have only 12 hours to use it. If I say 12 hours, when you are training your model and the model is running for 12 hours, you can use it. But when the 12 hours is due, it will, I mean, stop it. And not aligned. In a month, you have 30 hours. I think you have 30 hours. Yes, you have 30 hours where you can train a cell only 12 hours, a single cell only in a 12 hours. So what we are going to do is that we'll be changing this. Immediately you change your accelerator, the session will renew itself again, and you need to run all your script again. If you don't run your script, it will be wrong. Okay, so I'll only run from this place, and I'll show you how to do that, so I don't need to run it. I'll only run from here all the way down there. So let me set those things first. And once I set it, then you will know. So here, the first thing I want to know is I want to check the device that my model is built on. So check the device the model is being run on. So if I say the device, there are 2. That is, they are even 3. They have the TPU. They also have the CPU. They also have what? The GPU. Okay, but this one, you see that when you click on this, I think you saw the TPU, right? But that one is, they won't give it to us because I mean it's not free. You need to pay. All right. So we are going to check the device. So how do you check the device? Okay. So we have next here. Then you take our model. Then have our parameters. Then let's see the device our model is actually running on. Okay. So nothing goes wrong. It tells that, oh, it's on the CPU. Why? Because it's true. You see here, if it is set to none, that means it's running on the CPU. Okay. Kaggle CPU, not our CPU. It's running on Kaggle CPU. So that's why even if you are using a very bad, computer, if you can go on the internet, you can do any project at all. It doesn't matter. We're not going to rely on your CPU. Okay. So what we are going to do is that we need to set a device ourselves and put our model on. And the device we want to set, we want to make the device GPU. And the GPU, they are faster because they promote or they use something as well parallelism. Okay, so it's able to run on a parallel something. Okay, CPU uses sequential. Okay, although uses sometimes your system will have more cores, but the GPU is faster than the CPU. So what we do is that we need to move our model to the GPU so that things will be okay. So we have device is equal. Now the is forgetting the full thing, but we are checking if you have CUDA on it. So we are saying that device CUDA. If touch dot CUDA, okay, is available, sorry, available, okay, else use CPU. So what we are saying is that you check the if GPU, let's use the GPU or else use the CPU. So let me change this straight away to this, the T4, this. You see, it's telling me, I click on it, turn on. Once I turn on, you see that it stopped the session. Now, the session is stopped now. So that means I need to rerun my things back again. So a quicker way to run, you don't need to be, doing press shift enter, shift enter. So you click on this cell, then you go to run. When you go to run, you run and after it will run now. Let me click. GPU uses data, papa. A data rough is slow, forget it. Best is another data, then also best is GPU no treat data. I have to be honest. A treat data rough. All right. So let me run from here. You say it's not defined. I don't know what's wrong with this. Let me run again. So run current and after. So run current and after. That's what I need. All right. So you're missing the import. Wow. So I need to go and I need to run the libraries. Sorry. If I don't run the libraries, I can't run the down one. All right. So let me run the libraries. Okay. So it's not running. So I can go and run the down one quickly. Okay. So we are almost finishing this. I know you've done well. So so run current and after. Let's see. Okay. So it's done now. So let me come down here. Why are you not going? Okay, so let's print the device. You can type the device to see what device that we are on now. So first you saw CPU, right? So now that I see that the device is now CUDA now, that means I'm using this instead of the CPU. Okay, I'm using this. And that is the order of the day. Okay, we want to use the GPU. The GPU is far better than the CPU because the CPU struggles a lot. Okay. So now that we've moved or we know where our device, our data, our model is now, okay, now that we know where our model is now, if I copy this one again, which is again, all right, I copy the next again, I have to move my model to the GPU, and we have to do it. You have to do it explicitly, like one move you more than I go GPU now, it will not work. Although we've set the system that we want to use the GPU, we need to move our model to the GPU, and we have to do that. If we don't do that, forget it. It will not. Okay. So the GPU that we set it to device. So let's move it straight away. So here we set a model to GPU. Okay. If you don't do that, okay, because we know it's available, that's what I'm saying. Now, if we didn't, we're not having the GPU, no need moving it to the GPU because by default it's already on the CPU, right? But since we move it, let's do that. So model version 2, I made it version 1, Yeah, version 1. All right. 2, then device. So we are moving it to device. So we are saying I'm moving to the GPU. So next, model version 1. Okay, dot parameters, then to the device. Let's see. You see that to tell you that the model has been moved towards. Have you seen it? To the CUDA. It's now on the CUDA now. All right. Now, so we don't want to waste time. What we do is that we have our loss function. So let me even make here. So here I can see what set your device. We create a model. So here I can see what set the device. The device. Okay. So next thing is I need to create my loss function. So let's have the loss function here. The loss function we already have it at the top. We just have to go and copy. I don't need to type. So we done it at the top here. Just have to copy my loss function, which is the same thing we did at the top. Where is it? Okay, so this is the model. This is the model for the loss function. Yeah, this is a lot. So we have a lot function, we have optimizers, everything. You can use the Adam, all those things are up to you. You can check or explore more. Then instead of me using this, maybe I can use 0.3, who knows? So I can even go a little bit down. All right. So as I said, you can check your different loss functions. You can do that. So let's run that. All right. So model is not defined. Yes, it's true because I made it in version 1. So I need to change it back. All right. So to do the calculation, once we now have to move all our data set to the device. If you don't move your data set to the device, it will not work because the device, we created the device on, sorry, we created the the data set on the CPU. So what we could have done was here, when we were creating it, we could have moved all the data set straight away to the device. But because that's why I take my time. If I'm going to put it, once I do my splitting, so here, once I do my splitting, I move all of them straight away to my device straight away. I don't need to come and do it again. But because I'm doing tutorial, that is why. So I wanted to show you the devices. So let's move our data set to a device. So still on it, so we can, or could have even done it here before even the loss function because we even do that. So let me put it over here so that I can have it. So okay, the data set to the device. Okay, so we have our X string is equal dot as tensor. That means we are converting to tensor. Then we set a type to float, but we also move it to our device. So we have it here. Let me copy this quickly. Okay, then paste it. It should be what? X. Okay, or I should make it Y train straight away so that I don't get confused. So Y train rather because they go together. Sorry. Y train here to become what? Y train. Then I copy these two, I change it. Okay, so here becomes what? X test. Then here to become what? X test. Then here to become what? Y test. It become what? Y test. All right, so we have this. So I move all of them to the device. So X train, Y train, X test, Y test. I move everything to the device. So now that I've done that, I mean, I'm good to go. Because if you don't do that and you try to know your model, you have an error. I have to be honest. Because you move our model to the device, but your data set is on the CPU. So since you move your model to the GPU, you need to move all your data set also to the GPU. So now that we are done, we need to now train our model. So let's start with the training. So here, okay, so train a model. So we are done. All right, so let me go and copy the train because I already have it over here. I just make some changes to it. So Control A, Control C, I copy everything. I come here, I come and paste it and do my changes. All right, so I paste it. So here, let's go through what are the things that. So here, we are not going to collect anything. What we are going to do, since it's 3D, I have to remove all these things. I don't need it. So the number of epochs, I think I have to still leave it at 10,000, but that's quite a lot. I think 1,000 will be fine. Let me go to 1,000. Then I'll set range. I put my model, which is version 1, to train. Okay. Then I do the same thing over here, which is version 1. Set the X string, we pass it to it, we calculate our loss function, the same thing. But here, if you remember the Y train, here, there was something like this, and I told you that we'll come back to that. Here, you see the Y, this one is not a matrix, it's going to conflict with us. You need to find a way to reshape this. You have to reshape this, or else, you see, those of you who did electing mass. When you're multiplying matrix, you say what? Column number must be equal to row number or whatever. So we need to find a way to reshape this, like to seal this, or else you'll be in trouble. It will not work. We are going to have an error. So inside our calculation over here, which is the loss function that we are going to do, we have the predict, which is still intact, but the train, we have to put it in a format that will match our thing. Okay. Then the graph still remain the same, backwards still remain the same, optimizer still remain the same. Then we have version 1. Okay, we evaluate it. Then here we touch infinite down to remain the same. Right here must be version 1. Then we calculate our test loss. The same to do the same view over here because we are supposed to change that. So which is a view -1, 1. Then yeah, we just have to do. We don't need all these things, so I can take all these things all the time. So we just come here, yeah. And here epoch is the epoch, then train loss, so I don't need this because this has to be quick. Then test loss, true, whether I've not made any mistakes. So 1000. So here has to be 100 because I'll go 10 times. So here one model version 1, model version 1. I do that. Set one, set version 1, version 1. Okay, so I'm set, good to go now. So let's train it to see. And after that, we will now try to print some stuff. If nothing happens, okay, yes, it's happening. The size of the tensor must match the size. All right, so where's the error? So I was printing, shouldn't happen to me. The size of the tensor must match the size. Where's the line? Where's the line? I think here. Make a mistake here. Let me check the correct thing. Sometimes. Okay. Sorry. To be, it's supposed to be train radar because I'm calculating the loss. Oh, what a mistake am I been doing? Oh, sorry. Oh, okay. It's supposed to be at the top here. All right. So the top here, we have X train. Then, let me even check. Oh, that is the correct thing. Y train, X text, Y text. Okay. So we have our X function, Y predict, Y train. Then we set the view to this. I wish I could be able to see the view properly. I'm coming. Let me test some of these things. All right. So some of these things, you just have to see how the thing actually is. So Y train is actually what? I want to see something. This Y train, if I get the shape, let's see. I'll be quick. So the shape is this. So put it in a view mode. A view. Negative 1, 1. And I pass the shape to it. Let's see what I'll get. Yeah, that is correct. 160, which is 160, which is correct. I have to agree with what is over here. Then the Y predicts. What do I predict? Y predict with inter. There's nothing wrong. So what is happening to my thing? It's saying that blah 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 to input some 160. This will likely use an incorrect result due to a broadcasting to ensure that they have the same size. If you are making a mistake with the values I'm doing over there. But there's nothing wrong. Y predicts is this. Then loss function Y predict, Y train. Put it in view. That is correct. So there's something wrong with doing somewhere. I'm making a mistake. Let me see. Guys, give me a minute. And sometimes some of these things I have to go through carefully so that I don't miss anything. I'm being tired. I'm exhausted. I have presentation tomorrow. And I'm on the call teaching you guys like that. Coming. I want to verify where the error is coming from. Alright, so here I have my loss. which is the loss, which is what is the loss? Okay, loss, which is the function loss, then y predicts, y train, then I put the view. Okay, in that format, okay. Then there's nothing wrong over there, but also do that. So let's see whether the model is where the mistake is coming from. Okay, there's nothing wrong somewhere. Show me where the error is. Show me where the error is. This will likely lead to inquiries or due to broadcast. Please ensure that they have the same size. Return these targets. The F1 loss. This over here. The Y predict and the Y train. What's the greatest in there? Extreme rather. But it's supposed to be the same thing. I'm even using the wrong thing. Oh, sorry. This one I don't need a view. It's correct. Oh, I'm making a mistake. Extreme. You have this, you have this, you have this, you have this. I don't know where the error is coming from. Oh, I have to track it quickly. I will die though. Oh, I made a mistake at the top here. Let me see here where extreme word trainers test word test. Okay, this test word train. Okay, nothing wrong anywhere. Then I have my loss function. There's nothing wrong. I set my parameters to correct. I think this is the training where I set my model to train. Now what I predict is the model then X train. Okay. And I calculate my loss using the Y predict and the Y train. Then I set my optimizer to grad. Then I do my backward and step. I put a model in evaluation. Then I see that okay, we touch. Alright, so test predict is equal to the model X test. Okay. So here test loss equal to loss function. Test predict then Y then view. Then bam, it's giving me that I'm not broadcasting this thing well. Or the target size is 40. But the mistake is from here. What mistake am I doing now? I think I mess up with the calculation. I mean, let me view all the shapes again because maybe I made a mistake. Shape, the next shape, y text. Because I think one of the shape is wrong. All right. So anytime you are running, you have an issue like you can stop the session, okay, or you can restart and clear all the output. Let me stop this thing quickly, wasting time. Then I count my session is already there. So let me run it at the top quickly. Get this one done. Start the session again. Be quick, be quick. Oh, this error wasted my time. But I made a mistake. So I'm really surprised. Okay, it's done. So I can come here and run from here. Let's see. Oh, I'm in trouble. Oh, I'm going to run all these things. Going to waste time on. Okay, it doesn't matter. Let's see what happened on the top there. It's still giving me the same thing. Oh. Shift test. Why is the test 40 here? I made a mistake somewhere. Oh, should be at the top here. My test is 40. Or maybe I didn't do the fitting well. Let me look at the fitting. Sometimes when you are fitting, let me check it. But yes, a string scalar. Are you there? The mistake was from here. Supposed to do the test. Rather. Thank you. Let me clear outputs again. That's why it's not working. So let me clear, restart and clear outputs. Then go to the top. So this one is still over. Let me run this cell. That's what's important to me. Once it's done running, I can go and run the other one. So this time should work. Oh, this thing wasted time, pal. See, so come to running. Run selected and after. Let's see things quickly. I don't think we have any error. Okay, so let's look at this. Hey! This is our error. There's not going anywhere. Oh. I think the loss function is bad. Have you seen it? It started from 13 and it's coming to 10. I mean, it's not dropping. It has to drop. But some of these things I'll leave it for you guys to go and make it better. All right. So yeah, you're supposed to drop cry now. We cry and you can't do anything with this. Okay. So bad. So bad. So what we'll do is that we'll just evaluate it then because the rest I'm thinking if the loss function is bad, you make it one. Then what again? Maybe I'll try to make this 1,000. Then I just maybe run it again. You see, let me run back again at the top there. Let's see because the value is so bad. So let me click on run current and after, and let's see. If you don't get a good value, these are the things that you're supposed to. Wow, it's falling. It's falling. That means you see, it's falling. I mean, if I should increase it to let's say 1 million, I mean, if I add another zero, one, maybe I don't know whether 1 million will help. Okay, let me increase 1 million. Then I'll change here to 1,000, and let's see whether the value will fall a little bit for us. Okay, so sometimes you need to increase the number of epochs, the number of exposure. I mean, you give to your model. Okay, so that you run your model over and over again. So run current and after, and let's see because what we are getting is not going to help. So let's see 8, 7, 6, 6, 5, 4, 3, 3, 2, 2, 2, 1, 1. Supposed to fall below 0, four below one, four below one, four below one. I don't think to go again because it's still, if you look at it, so here, this is how far the model can go. So I think it just here. When it gets to the 1.27, that is all. It's not going to fall again. So when it happens like that, you say that your model is not learning anything. Have you seen it? So here the model is learning nothing. So the model learned all the way to the epoch, which one? 18,000. Then the rest, no, 19,000. The rest is not learning anything because it's still the same thing throughout. So you need to either, all you do is that, all you can do is that you can change. You see, it's going, but nothing is happening. Have you seen it? It's still saying the same thing. So here the model is learning nothing. So what happens is that either you go and change this. This is too much. Or you can even change the loss function. You can even change the optimizers. These are all up to you. Okay, because nothing is happening. So I don't want to waste time. Okay, so it's up to you for you to do that. So let's try to evaluate it to see how our model is actually doing. And we go. Okay, so here, so find our model and parameters. Find our model's length parameters. Okay, so here from pp print, so we import what? Print. We import what? pp print. So the model. This one is not learning because it's still saying the truth. I'm just wasting my memory. Model length the following values for weight and biases. Okay. So I'll use the pp print. Then our model version 1, auto states. Okay. So what it can go, but it's going all the way to. I mean, it's doing that. I should have been stop it because I mean, it's doing that. But let's wait for it to finish. Then let's evaluate our model. Okay. So let's evaluate the model. All right. So turn your model, set the model into what? Evaluation mode. Sorry, mode. So which is what? Model version 1. Dot what? Eval. We have this. So now we can make prediction now. To make prediction. Make prediction with touch. Dot inference mode. All right. So y predicts. Go to model version 1 or x or test. We just test it. Then I think that is all. The rest is we just get our evaluation metric. Then it's supposed to run this first. Run this one, then run this. So let's get our evaluation metrics, and that is so evaluation metrics, which we have the root mean squared. So mp dot square root mean where error y test predict of the r squared squared error predict. That is all for the copy. I'm being hey, So they run. I don't know how many I go. How many? Whatever. Fine. That's fine. I'll run again from the we'll put out the top and let's see. So run carrot after and go down there and do my pasting. This is what get going to run it also. Before it was where is it? Okay, so guys, I think that is all. That's the end. So, I mean, I'll pause here. Yeah. So it's training. So let's wait for it to train. It will further. I think the model is bad. I mean, I think what I do wrong. Did what? Can't convert CUDA. Oh, I'm supposed to get it. Yeah. You're supposed to get this one straight away. Oh, I think .cpu .to numpy. I'm supposed to do that. The same thing over here. Dot. Not even work. I'm coming again. So y test equal to y test dot what CPU. Yeah, they did the same thing also for what I predict. Once you move them to the once you move them, I don't need that to not work. Or CPU. Before I can do any calculation with it, I can even add the NP right straight away to yes and to do the calculation for me. Okay. And this one goes off. Okay. What comes here? All right. So let's see. R score has not really touched. Oh, did I put it as okay? John was number plus. Okay. Not define. Oh, see what I mean? Sorry. So let's look at it. So I'm done. So you see, our root mean square is even this, and this is okay. So here, I mean, we have to sit down and try to make this one better. I don't know whether this one is 0, so I should just make it 0.1 or whatever. So it all depends. So when these are the things people spend nights, day and night to work, and you see them building AI systems and all these things, it starts from here. They start from here. Okay, so it's not easy like that. Okay, that is all. Right. So okay, it has come down small. When I change it, has come down small. So which is fine. Yeah. Fine. All right. I don't know whether some of you will find a way to let it go down a little bit. I don't know. All right, but the Runion square is fine. The outlook is fine. All right, so guys, I'll pause here. All right, you've come far, so let me start recording.